So welcome from my side and welcome everyone. And yeah, thank you for giving me the opportunity, Sabrina, to speak about a small side project I've been working on the last 9 months. I start sharing my screen and then we can start the presentation. One moment. Okay, do you see it? It should work. Okay, good. Okay, so basically, as Sabrina already said, I've been, I'm a visiting scientist at the European Center for Medium Range Weather Forecasts and also a PhD candidate at the University of Marburg. And I've been working on a small project the last 9 months to bring in a subset of ERA5, which is a climate reanalysis data from ECMWF to Earth Engine. And the talk is about the data set itself, but also challenges which actually come or appear trying to bring data from one data system to the other and bringing different user communities also together. Just a bit of background to me and also how I actually came to this project. So for the past 5 years, I've been working in the intersection between data provider and data users. I've been working at ECMWF. I joined ECMWF in 2015 and I've been working on a project where we investigated a third-party software trying to make open data, and specifically at this time ERA interim data, better accessible to users, so that users actually don't have to download data anymore, but they can just access the data and integrate the data into their workflows. And so, and this project gave me like a lot of, contact with data users and also a bit of understanding from the data provider side, but also the needs data users have and also interests data users have in actually using ERA5 data, climate reanalysis data, and also some challenges non-expert users have. So like users not coming, not having a meteorological or climate background. And yeah, so this is basically, and then, yeah, because working on this project and now my PhD is also the next step further to actually trying to see how we can set up more on-demand data services in the cloud. I became a bit obsessed seeing and trying how to make open data better accessible to users. On the right side, you see some icons. So I'm, how do you say, I like to work with. So I'm working a lot with Jupyter notebooks. You also see Python and R here and design for OSGeo. So I like open source in everything I do. And Python and R, because I want to stress that I don't want to put myself as an R person or a Python person because I like both languages and I think they're good for their specific things. So I like to work both with Python and R, and specifically I like to combine it in Jupyter notebooks. And I'm also quite active in a newly founded community, Women in Geospatial. I started also using Earth Engine around 5 years ago as well. But since I joined ECMWF, I have more the perspective from a data provider perspective rather than a data user. So the talk today is more about how to actually ingest data into Earth Engine and also for you to see what a new data set is available you could use. Can I now? Okay, so a bit of background to ERA5 and the climate reanalysis data set. So it is produced by the European Center for Medium Range Weather Forecasts as part of the Copernicus program. So ECMWF is running 2 Copernicus surveys, the climate change service and the Copernicus Atmosphere Monitoring Service. And ERA5 is one of the most popular open data sets as part of the Copernicus program. It has a total of 137 different atmospheric parameters, and the entire data volume of ERA5 results into a 5 petabyte large data set if you would access like all the 137 atmospheric parameters, etc., and on different pressure levels, etc. It has a spatial resolution of 25 kilometers and a temporal resolution hourly. So the native data set has an hourly temporal resolution, but the data is also now available as monthly aggregates and daily aggregates. So as I already said, I would like to focus today more how we can actually make the data better accessible, because data access, in my opinion, is one of the most challenging part at the moment, trying to actually work with big and large volumes of geospatial data. So we could do the processing in cloud environments, and also Google Earth Engine is there, like a really very, very helpful to help us with the processing of large volumes of data and also the visualization of our results. But the access of data is the most challenging part. And specifically, if we try to bring different data to different user communities. So in my case, I work a lot with meteorological and climate data, and but then the Google Earth Engine is, for example, strongly used in the Earth observation community. And so there are different data which are accessible in different data access systems, but often it's also the case that actually the data is of interest for a lot of applications. So not only within your community, but also for other communities and other data users. And also, like in the case of ERA5 data, it is available in the Climate Data Store. But if you want to access the data, there is a toolbox which is similar to the Google Earth Engine, which allows you to build online application. But it's still also about downloading data. So if you want to access the data, you have to download the data, and then you can actually process them on your local machine. And then, as everyone probably knows, there's community-specific data formats. In the meteorological and climate community, we like the GRIP format, but there's also NetCDF. Earth observation data is often with intuitive. And then another challenge comes with meteorological and climate data, specifically if someone is not from doesn't have a meteorological or climate background, then the data structure can be quite complex, because the data can have up to 5 different dimensions. There's different data sets. There are analysis and forecast data who are different, and yeah, you should understand what the difference is. Otherwise, it's easy to actually misuse the data. So this brings us to actually that we all operate still on different islands, depending on what community you're mostly affiliated or with. So we have the Earth observation community, which is a community itself, and then we also have the meteorological and climate community, and we all have our own data and data access systems, data formats, etc. It comes to challenges if we actually want to bring these two communities together, and we also want to inter-exchange the data. And this was the idea, as long as we still have two different different data access systems where we have to download the data, we have to investigate more or put more effort into actually bring the data to other user communities. Otherwise, the open data is not fully exploited. So as I said, I've been working on bringing a subset of ERA5 data into Earth Engine, and I would like to share with you some numbers, what it actually means to bring in some meteorological climate data into Earth Engine. So the idea started around, about this time last year, and we started to discuss, okay, that we could start with a trial to bring in maybe the most popular data sets for applications, for example, 2-meter temperature and total precipitation. Then we discussed, okay, like in what structure should we actually provide the data, which resulted that it would be best to have the maximum flexibility for different applications, to have 3 different image collections, like based on hourly, daily, and monthly data. And then, as you already see on the slide, it didn't stay with only 2 variables, because we made a small survey on the Google Earth Engine developers list. And then, yeah, a lot of people got excited, and we came up with a subset of 9 variables. So we have now 2-meter air temperature, the minimum, the maximum temperature, and also the average temperature, 2-meter dew point temperature, total precipitation, surface pressure, mean sea level pressure, and 10-meter U and V component of wind. And all these like variables, so it's 9 variables, but 7 parameters, because the minimum and maximum temperature has been computed based on the hourly air temperature parameter, which was downloaded. It results in around 7 terabytes of data, which needed to be downloaded. It resulted in 104,000 single data files, which needed to be stored. And because the data was downloaded on a daily, as daily files, and it resulted into 243,113 data files uploaded to Google Cloud Platform. So it's a lot to actually move 7 terabytes of data and this amount of data files, and also downloading it, uploading it, etc. To have an overview how the workflow actually looks like, I prepared or tried to make a graphic, because it takes advantage of very nice APIs. So the entire workflow is based on Python, and it's not only the climate data store where we actually get the data from, like the ERA5 data, and then we bring them to Earth Engine, but we also made use of the Google Cloud Platform. And so basically the workflow is that we download the data with the CDS API in netCDF format. We store them on an external hard file or on a server somewhere. And then because we had three different image collections, we resampled the data into daily and monthly files, and we also needed to convert the data from netCDF into GeoTIFF with GDAL, because in Google Earth Engine we can only upload or ingest GeoTIFF data. And so the TIFF files we uploaded into Google Cloud Platform into different buckets. So we ended up having 27 different buckets for each parameter, and also for each resample of each parameter. So we had 3 buckets for each parameter. And then these URI IDs from the Google Cloud Platform we used in order to create image manifests. And this is basically a JSON file where we describe the asset, the asset ID or the asset we would like to ingest into Earth Engine. And the Earth Engine can be now linked with the Google Cloud Platform with the help of Google Earth Engine API. And with the help of the Earth Engine API, which is a Python API, we can actually upload the image manifest. And I think now I lost everyone, but I tried to make it a bit more, at least to show you how an image manifest looks like a JSON file, which we then can upload with the Earth Engine API. And so basically it's a JSON file where we define our Earth Engine asset. So at the beginning, like you see the name at the beginning of the JSON, and there we define in what bucket we want to upload our image or our asset. So in this file, it was ERA5 daily. And then we can define the bands or the different bands of our asset. And here we define the Google Cloud Platform URI. So we, from the Google Cloud Platform storage, we can take the individual URIs and we say, please take this data set from the Google Cloud Platform and ingest it into Earth Engine. And so in the second step, we can define the different bands. So here, as an example, I just said we want to have 3 bands, but in the real case, we ended up with having 9 different bands. Oops. And at the beginning and at last, you can define, so you give your asset a date and timestamp and some properties you want to have. So in our case, each asset was based on a time, so on a day or on a month or on an hour. And so we brought on for each timestamp or date time information, we made 9 bands available. And so once we have this manifest for each asset we want to ingest, we can use the Earth Engine API via a command line tool, or a command line tool, and we use Earth Engine. Then we can, we want to use the flag, use Cloud API, upload image, manifest, and then we can define the manifest JSON, which we just created. And yes, but still in this workflow, so there's already a lot of great tools which make it very smooth, and you can also automatize this workflow a lot. But I would like to stress that it's still very cumbersome to actually bring in to bring in the data into Earth Engine. So, and there are 2 major bottlenecks. One is to actually need to download the data, need to convert them, and then need to actually the data as assets into Earth Engine. So assets are not modifiable, and so this makes it also very cumbersome. So we had one case that I uploaded the files and the resolution, not a resolution, but a grid was shifted by ½ degree or by ¼ degree. And so this means we can't just update the assets, but we needed to re-ingest all the assets. And as one doesn't store the data naturally or leaves the data on Google Cloud Platform, so you have to upload the data again on Google Cloud Platform, and then you can re-ingest it again to Earth Engine. So yes, it's not ideal, but yes. So there are a lot of challenges we still have to work on. So yeah, the data is now a part of the public data catalog. At the moment, the daily aggregates and also the monthly aggregates are available. And you see here, so you have the links here. I will show you just in a minute how it looks like in real. Then you have some information, and there's also an example which you can directly load an example, and you can visualize the data with common color palettes. And yeah, so this is one example of surface pressure, how it looks like, but I would like just to show you this in real. And so basically this is the Earth Engine data catalog, and yeah, you have here a small script which shows you the different data, the different parameters, how you can actually load them, and you can also select the different parameters. And for each parameter, we defined also a visualization palette, which makes it easier for you to actually visualize the data. And yeah, and we can basically load it. So this example is for ERA5 daily. We can load it into Earth Engine. And then we can let it run. And so this example basically now loads, yeah, I think almost like 5 different layers. So total precipitation, 2 meter air temperature, 2 meter dew point temperature, air temperature, 10 meter U component of wind, and also the daily mean surface pressure. And yeah, so this example we just saw on the presentation. And yeah, so we can also, yeah, so this is 10 meter U component of wind. This is temperature. This is dew point temperature. And this is total precipitation. And then I go back to the presentation. And yes, so this was just a short overview on like, yeah, how data, like how large volumes of data can be actually ingested into Earth Engine. What's next, also specifically with the ERA5 data set, because there's a lot of interest. A lot of people also ask for other parameters they would like to see. And it's not only the ERA5 now, there's also a subset of ERA5, which is called ERA5 Land. And this has even a better spatial resolution with 9 kilometers. And there's also a big interest to actually have ERA5 Land in Earth Engine. But as I already showed, that the process is, it's very time intensive. And I think for now, I will focus more on finding out how we can actually decrease one of these bottlenecks to maybe not download the data or just move some of the converting steps into yeah, not having it on your local machine, but making advantage of one of the cloud cloud services which are set up as part of Copernicus now. But yeah, as I said, at the moment only daily and monthly files are ingested, and the next, so now at the moment I'm ingesting also the hourly files, and this I did at last because in the end we will end up with around 360,000 assets. And each asset having 9 different bands. And so we want to have everything right before we start ingesting all these, this entire amount of assets. And so, but yeah, so we are there, and I'm just, yeah, about to start a process and hopefully be finished in, yeah, before Christmas. Let's cross fingers. And then I also, so because a lot of people ask also for other parameters, and I can't commit to providing any more parameters into Earth Engine, but I'm happy to provide or to making the workflow and also the Python code available on GitHub. But before I have to clean it up. And then with this Python code, because yeah, it's quite modular, and I define different functions, it should be quite straightforward to ingest any other parameter you would like to see. And I also provided some resources for anything. So if you would like to get more information on the ERA5 Climate Reanalysis data set or the Climate Data Store where you can access the data, then some libraries I use or I used, so like to download the data, the CDS API, and also X-Array, which is like a very great library for, it makes it very efficient to work with meteorological and climate data and netcdf files. Yeah, then the Google Cloud Platform and the Google Cloud Storage API, and at last the Earth Engine API, and also some information about manifest uploads. And with this, I would like to conclude my presentation. And if there are any questions, I'm happy to respond if I can.